staggering things that you might think about is if it's true that something like Jupiter is required to have the Earth form, in the place where it does, not closer than Mercury, not bigger than Jupiter. If it takes having Jupiter form out there, the question you might ask yourself is how many stars in the sky have something like Jupiter? And the answer seems to be something like about 1%. So it's not quite dark enough to look outside at the stars yet, but as you leave here tonight, I want you to look up in the sky. It's a nice dark spot. I think you will probably be able to see around 2,000 stars in the sky. Of those 2,000 stars that you can see, I'll get them to turn all the lights off around here before I go. So of those 2,000 stars you can see, I want you to think about that 20 of them have something like Jupiter going around them, which means 20 of them maybe have something like the Earth around them. You might think that's a pretty small number, but you can also think that that's actually an amazing number, that you can look up in the sky and think there are 20 places where a place like the Earth exists, where the conditions might be right to have something like life emerging in these locations. But there's an important question that we haven't addressed yet, which is, just because you have conditions like the Earth has, what are the chances that you have something like life actually develop? If we started the solar system from scratch, would we all be here? Or was it just some really random occurrence that led us to be here? And the answer is, we have no idea. We have one example of a place where life has occurred, and you need to go in from the stars that Constantine was talking about. Let's say that 1% of these things, maybe one on the screen, has an Earth around it, and we really need to dive into the solar system itself and really try to understand how life emerged on the Earth, and whether it's very common, such that there are 20 stars in the sky that actually have the high probability of life, or whether it's very hard, which means there's not much chance that there's anything out there at all. To answer that question, we could start by going to our favorite planet. Everybody's favorite planet? The Earth. There it is, Mercury, Venus, Earth is right here, following along. And so let's look at the Earth and think about the Earth and try to think about how we would understand how life and when life emerged on the Earth. I'm going to show you a timeline. I'm sure all of you took and memorized your geology in college and high school. And you remember? No, okay. So here's a timeline. Today is right here. And 4.5 billion years ago, it's the time when Constantine was talking about the solar system forming, Jupiter forming. That's over here. We think that life emerged somewhere right around here. Origin of life is somewhere before 3.5 billion years ago. And so if you want to study the origin of life, you want to look at the chemicals that were there, the environments that were there, you need to go find rocks that are 4 billion years old. There's a big problem with that, which is you can't. The rocks that you look around are really not very old. If you look around here, San Jacinto, anybody know how old the rocks are that make up San Jacinto? It looks like it's this grand peak eroded like crazy. Anybody know? Put me on the spot. No? I told him this. He didn't know before. 100 million years old, right here. That it looks really old. These things right behind us here look super old. A little bit older we can find if you go out to the Joshua Tree and look at those granites that are eroding away, looking like they've been around since the beginning of time. They're about right here. It's where the dinosaurs are, not just Cabazon, they're right here too. And if you try really hard, you can find some older rocks. If you go up to Yucca Valley and you take a left in Yucca Valley and go up to where like Pioneer Town is. Has anybody been to Pioneer Town?
Yeah.
Why? But if you go up there are actually some really old rocks up in there. And actually, do you know the place you can find the oldest rocks that I know of in this area? Anybody know? On the walls over here. There's some just beautiful gneiss. It's actually called gneiss, G-N-E-I-S-S, not N-I-C. There's right here, as you walk out this way, do you guys know this one? There's this whole panel of rock. Right there, I can see it from here. And there's another one at the bar. If you look from the other side of the bar, go check those out on the way out. Those are probably the oldest rocks around. And they're not very old, they're probably right about here. They might be real. So we want to find life by looking way over here, and the answer is you can't really do it. If you look around the Earth, where do you find things that are like even older than 3.6 billion years old? It's these little gray spots on the Earth. There's a few. The famous one, at least to me when I was a kid, I always knew about the Canadian Shield, which is up here. This is like actually something like 4 billion years old, but very few other places. And the rocks look like, actually they look like this nice over here, there's nice over here, nice over here. This looks like also sort of like 2005 kitchen counters, right? This kind of stuff, like ours, looking at my wife. It's actually literally nice, that's what it's mostly used for. If you go back in time, if you go whichever direction you think about, a little bit past these really old things where you, like imagine trying to understand what happened here. This stuff has been heated and mushed up and it's a big mess. If you go a little forward in time to now 3.5 billion years, life has been around for 600 or 700 million years by now. And this is the first evidence we can find of really preserved rocks that still show the evidence of life. These things are called stromatolites. Maybe some stromatolites there. I got some. If anybody wants to like see these things up close, these rocks are fossils that are probably the oldest fossils that any of you will ever be able to touch. So I would love to share them. So come up and look at them. There are these little layers that you can see in here. They're basically slime mats that form in water environments. A mat of microbes goes down. Water goes away, water comes back, another mat goes down, and they make there's sand in between, and they make these mats. 3.5 billion years old, and if we want to understand the origin of life on Earth, this is the oldest we have, and we're 700 million years too late. There's nothing we can do. We cannot really do a good job of understanding the origin of life on Earth by looking at these places on Earth. So what are we going to do? Well, there's one place we can think about where we can actually see some really old rocks. This is not just the other side of the 10, like it looks like. This is, in fact, the surface of Mars. These are old volcanic rocks on the surface, dunes on the surface. It does kind of look like just across the 210. On the surface of Mars is very different from the surface of Earth for two really good reasons. One, it doesn't rain on Mars. It rains on the Earth. All the sand that you see around here has been washed down from the mountains. It loses its context. We don't know where it came from or how old it is. It comes down. So rain really erodes things away. You can't see them. The other big thing that happens on the Earth that doesn't happen on Mars is plate tectonics. Plate tectonics builds new rock by pulling the ocean basins apart. Rock comes in. We have volcanoes that come in. We have old rock. It goes underground, it subducts underneath these things. So we basically recycle the Earth's surface every 500 million years. 500 million years seems like a long time. That is something like a tenth of the age of the Earth. We really don't see much stuff that's older than about a tenth of the age of the Earth. Mars, in contrast, does not have any of those. And so if you look on Mars, all of this brown stuff, this is a map of Mars, I'll show you more in detail. But all this brown stuff is stuff that is older than 3.7 billion years old. 3.7 is kind of that key when life was starting to evolve on Earth and older than anything we can really see on Earth. All this brown stuff. There's younger stuff. There's stuff that's been covered probably in water. There's middle-aged volcanic stuff, but there's some really old stuff. And if you go look at that really old stuff on Mars, you see something really weird. That's weird. Okay, craters, fine, that's not weird. But one of the things you see is these things that look very much like river valleys. They look like what we would call dendritic channels. Dendritic channels means, it's the same word that we use for the veins in a leaf. It means, when you see that as a geologist, you think, it means it has rained. It rains here, and there's a little basin here, and the water flows, and gets down into bigger channels, and bigger channels, and bigger channels. 3.8 billion years ago on Mars, it actually did rain. It hasn't rained since then, but it did rain back in that. And this will matter here in a minute. But this really old stuff tells you that there was water on Mars 3.8 billion years ago, and that those surfaces, this surface is still here. This is a 3.8 billion year old surface. So, if you want to understand the origin of life on the Earth, the best place to go look, probably, is Mars. So let's go. So, as Tom talked a little bit about at the beginning, Caltech founded JPL, now manages JPL, works closely with JPL, and JPL, together with people at Caltech, sent, you guys, I'm sure many of you were here at this talk in, I don't even remember the year now, was it 2015, someone said? 2015. I was only 10. In 2015, you got to talk on the first big Mars rover. The second one has now landed during the pandemic, and it's landed in this amazing spot. Here's the amazing spot it's landed in. This is called Jezero Crater, and here's why it's amazing. First off, it is a crater that itself is something like 3.8, 3.9 billion years old. And you see two things that are key. One is you kind of see this river channel coming in through here like this, and breaching the wall. There's a crater wall. You know how craters go, you smack a crater in, it gets walls on the outside. There's high walls all the way through here. It breaches the wall and looks like it flowed into the crater itself. And then there's something, I'll show you this in detail in a minute, there's something that if you're a geologist or someone who likes to stare out the window as you fly across the country, looks like a delta. It looks like a place where water, or sediment and water flows into a big standing lake. Another really key thing is on the other side of the crater. Here's again, crater wall, crater wall, crater wall. Whoa! There's water flowing out the crater wall. This whole thing, 3.7 billion years ago, again, 3.7 billion years ago, where we have almost nothing on the Earth at all. This whole crater was a lake. It was covered in water. We think. So one of the things that you need to know is, one of the things you need to do if you want to try to study these things, understand the origin of life in a place like this, you need to go there and first make sure that you know what you're talking about. Was this really a lake? You know, we see these things, but you know, it's easy to make up stories when you see things. But you fly there and you land there and you can really understand what's going on. Here's an image that's sort of astounding. This is on the way down to land in this crater. And here's this thing that looked like the delta again. And the way a delta works is that the top of this thing would be where the water level was, and this would be where the sediment comes down. But let's see if this is really true. So we land in this crater and start to drive around and look to see what's there. And one of the most, this is, you might not believe it, but this is one of the most astounding pictures from Mars. Okay, it doesn't look that exciting, but check out these flat layers on top, things that come down just like this on a constant slope like this, and a flat layer down here. What is that? That's a picture right on the side of that place that we think might be a delta. Therefore, we think this might be a lake. And it looks like this. Why does it look like this? Well, here's an experiment you can do in the lab for entertainment. This is a layer of water. The water is right here, and there's sand coming down right here. And every once in a while, we throw in a little black sand just to make it, you can see what's going in. So you're going to watch water and sand come down like this, hit the water, hit the layer of water right here, and then build structures in through here. So let's go. Sand is coming in. You see the sand, it hits here, and it goes out, and it goes out, and it goes down like this. See how it goes down like this? As it continues to build, it continues to move out, and it looks just like that. Do you know why it looks like that? Because it's a freaking delta, that's why. There was a lake in this crater on